Hello everyone. In this video I've worked out the solutions to 9 different review problems from sections 8.1 through 8.3. You may want to pause the video as you watch and see if you can try these problems along with me. The answers are in the back of your textbook. Okay, 8.1. This section dealt with percent problems. This is number 43. A 20-inch flat panel computer monitor is on sale for $249.99. It was reduced $80 from the original price. Find the percent reduction in price. Alright, so one way you could show your work would be a proportion for this. We're looking for the percent reduction, and proportions are percent over 100, and then either part or over total, or sometimes the word is over of, whatever numbers are associated with those words. Okay, so in this problem, we're looking for the percent reduction. And we do know the amount of the reduction, the dollar amount. The sale amount was $80. Okay, and what we don't know, though, is the original price. So these percent reductions or increases are always out of the original price. So we have to go back and find that. Well, we know the sale price, $249.99, and we know the discount. So if you add those together, you can find that the original price was $329.99. Okay, and then if you cross multiply to solve the proportion, okay, equals 80 times 100, and then divide by $329.99. Alright, and you should find that the percent reduction is about 24%. Alright, a second problem, sales commission. Milo receives a commission of 6% on all sales. If his commission on a sale was $75.36, find the cost of the item he sold. Okay, so if we do a proportion, we know the percent, 6%, 6 out of 100. We also know the commission. The commission is the 6%, so that's the top number in the proportion. And then the bottom number, this would be the total that matches 100%. That's the cost of the item. That's what we don't know. All right, and then if you cross multiply and divide, you end up with the cost of $1,256. If you like an equation, if you prefer that to a proportion, then the question would be 6% of what is $75.36. All right, and then same thing, you get the same answer for x. Okay, and then a third problem from section 8.1, a percent decrease problem. Okay, so right away we need percent over 100. Percent is what we don't know. All right, in 1992 through 1993, there were 20 teacher strikes. In 2006 through 2007, there were 8 teacher strikes. Find the percent decrease. All right, so if we have the percent decrease, then we need to know the amount of the decrease. All right, so 20 minus 8, the number of strikes has dropped by 12. Okay, so in the numerator here, we have percent decrease, amount of decrease. The bottom here is the total percent, and then over here should be the total number of strikes. Well, we have two options. We have 20 and 8, and you always choose the original amount. So if the percent has decreased, then we're looking at the first school year. That's going to be the original or the old amount, the 20. Okay, cross multiply. Get 20x equals 1200. Divide by 20. And x equals 60. Okay, if you solve this using an equation, you'll get 0.6, and then just remember to move the decimal place since this is a percent, so this is 60%. Okay, section 8.2 was a section on simple interest, so in all of these problems we'll assume simple interest. In addition to working and her family's contribution, Jane had to borrow $8,000 over the course of 6 years to complete her education. The interest is $4,046.40. Find the rate. Okay, so we need to use the interest formula for simple interest, and then we need to solve and find the rate. So that must mean we know the interest, the principal, and the time. Yep, and we do. We have the interest, $4,046.40. The principal is the amount that she needed to borrow, $8,000. Okay, the starting amount of that loan. We don't know the rate. And then we need the time, 6 years. All right, so in your calculator, you need to divide the interest number by both of these numbers to get R by itself. Okay, so divide by 8,000, also divide by 6. Okay, you can enter it in just like that. And this one doesn't specify how you should round, so we'll just choose the same answer that your textbook has in the back. Okay, this gives you, oh wait, I think this one is actually this is an exact answer. Okay, so it's a decimal, but it's exact, 0.0843, so that would be 8.43%. To pay for new supplies, Jiffy Photo Company borrowed $9,325 at 8% and paid $3,170.50 in interest. Find the term of the loan. So same thing, we're just solving for something different now. We need interest equals principal rate times time. The term of the loan, that's the time. Okay, time in years. The interest, we know that's $3,170.50. The principal, that's the amount they borrowed, $9,325. This time we do know the rate, 8% as a decimal, 0.08, and we're solving for time. Okay, so again, you want to solve for t, so divide the interest by 9,325 and also by 0.08, and you get t equals 4.25. So this is in years. You can leave this as is, or if you want to convert to months, your textbook gives that answer as well. That's 51 months. Okay, and a discounted loan problem. Okay, so remember for discounted loans, when you're asked to find the discount, that's basically the interest. All right, so that's our first task, find the interest. We're assuming simple interest here. So we have interest equals principal, which is $18,000, times rate, 0.05, times time, 6 years, and that gives $5,400. Find the amount of money the group received. So this finance group borrows $18,000, but the interest is paid up front, so they don't receive all of that $18,000. So the amount that they receive is $18,000 minus the interest that's paid up front. So they actually receive $12,600. Okay, and then find the true interest rate. So we want to go back to the simple interest formula and solve for R. But now this time we're making a change here. Instead of the $18,000 as the principal, we're going to use the amount of money that they actually received. Okay, so we know that the interest is $5,400. The principal, that's going to be the $12,600. We're looking for the new interest rate, so you're not using the 5% anymore. We want to know how much they actually paid. The 5 is the stated rate, but not actually what they paid. And then the time is still 6 years. Okay, so divide 5,400 by 12,600 and also by 6. And the rate, this one does need to be rounded somehow. This is 0.0714, etc., etc. Your textbook rounds this to 7.1%. Okay, section 8.3. Okay, this is compound interest, and we also had some problems with annuities in this section. A 25-year-old plans to retire at age 50. She decides to invest in an inheritance of $60,000 at 7% interest compounded semi-annually. How much will she have at age 50? Okay, so this is a normal investment. It doesn't say anything about an annuity, so we'll assume that this is just a compound interest problem. And you can see the keyword compounded. That's how we know compound interest. All right, so the compound interest formula actually gives you the future amount, which is what we do want in this problem. Okay, and the amount is principal. And here's the rest of the formula. Okay, so we need the principal. That's $60,000. We need the interest rate. That's going to be the 7%. We need n, how many times the interest is compounded per year. So if it's semi-annually, that means that n is 2, twice a year. And then we need the time. This one's not explicitly stated, but if she's investing at 25 years old and she wants to know how much she has at age 50, that's a difference of 25 years. So time is 25 years. Okay, so we just need to substitute those numbers into the formula and then solve. Okay, 60,000 times 1 plus 0.07 divided by 2 raised to the power of 2 times 25. And all of that, okay, I think that's it, yes. All right, this one I did simplify a little bit because the decimals were exact. So if you work out the part in parentheses, this is 1.035, and that's exact, that's not rounded. So that's fine to do. And then the exponent is 2 times 25, or 50. And then from there I used a calculator, and if you multiply that, then the future amount that she has is $335,095.61. If this hadn't worked out nicely with that decimal in parentheses, then I would have just left it as written at this line and just entered all of that in. Okay, here is a future value of an annuity problem. All right, so here's the formula. The future value is the regular payment times all of this. And t minus 1 divided by r divided by n. Okay, so n is the number of times the payment is made per year, and r is the regular payment amount, so that's kind of like the principal. Okay, so the future value of the annuity, that's what we're looking for. $200 is invested quarterly, so that is the regular payment. All right, we need a rate, that's 5%. All right, we need a time. Well, this is invested quarterly, that's how often the payments are made. So your n would be 4 times a year. Okay, and then n times t, time is 20 years. And then the same denominator, still that r over n. Okay, so I simplified a little bit on this one too. and this is 200 times 1.0125, if you work out that part in parentheses, to the 80th power minus 1, and all of that divided by 0.0125, and the future amount is $27,223.76. Okay, and then a final question from this section. All right, finding a monthly payment, and this is also on an annuity. Petty Marine Company has a long-term plan to expand to a second location that's actually near some water, so they want to start a monthly annuity to save $150,000 in capital over 5 years. The best rate they can find is 7%. Find the monthly payment. Okay, so we'll use the monthly payment formula, which is R equals A times R over N divided by brackets, parentheses, 1 plus R over N to the NT minus 1. Okay, so we're looking for R, the regular payment. We have a future amount, so this is the goal, this is what they're aiming for, so they'd like to save $150,000. That's the future amount they hope to have. The rate is 7%. Okay, and then N is how many times the payment is made per year. Well, if this is a monthly annuity, then that's 12. Okay, and then divide by 1 plus rate over N, okay, 0.07 divided by 12. N is 12 the time. They have 5 years to save this. Okay, and then minus 1. This one, the decimal here was repeating, so I wasn't able to simplify that. So the only thing I really did was just change the 12 times 5 to a 60, and then I just entered this as is in the calculator. Okay, so I did 150,000, and then I did times 0.07 divided by 12. You actually don't need parentheses there, but you can put it if you want to. Divided by, and then you do need parentheses around the denominator. We need another one around the parentheses that's there. Okay, you don't need parentheses around the fraction, just divide by 12. 0.07 divided by 12. Parentheses, exponent key 60 minus 1, close parentheses. Okay, and that equals $2,095.18. Okay, that's it for sections 8.1 through 8.3. Thank you for watching, and I hope that was helpful.